Hello friends, welcome back to our channel. This is another video on static timing analysis. In our previous videos, we already discussed various types of paths like register to register path, input delay path, output delay path, and in this particular video, we will discuss paths which are from input to output ports without any sequential element in it. That means they are purely combinational or they are just net delays. In this video, we will discuss what is the requirement, how should we constrain these paths. And now without wasting much time, let us get started. Friends, before looking into the input to output paths, the combination logic paths, let us quickly look into what type of paths we already discussed in our previous videos. So the first type of path is register to register path from reg J to reg B. Another type of path we already discussed, input delay path, that is from input of the port to the flip-flop. Output delay path, that is flip-flop output to the port of the chip. And the combination logic path, that is from input port to the output port. If you want to look into register to register path, input delay path, output delay path, I will give the playlist in the description section. You can go through it. And I make you sure that this is very knowledgeable playlist. You must go through it. You will definitely feel elevated in your knowledge, either you are a fresher or a experienced person. Friends, in this video we will discuss what is the requirement to constrain input to output paths. How should we constrain these paths? Friends, I am considering the first category of paths where only single input is passing to single output. That means there is only a single line that is going from input port to the output port. And there are two types of it. One type of path is which is just a net delay. There is no combination logic also in between. Other type of path is when from input to output there is a combination logic in between, but there is no sequential element. In a nutshell, in this category of path, I want to say that there is only single bit that is traveling from input port to the output port. It is not a data bus. Friends, just consider it that this input port is coming from chip 1 and output of chip 1 is coming from one flip-flop output. Similarly, output of this FPGA output port is going to chip 2, which is ultimately received at another flip-flop inside the chip 2. So this path from flip-flop inside chip 1 to flip-flop inside chip 2, it becomes flip-flop to flip-flop path. So in this case, we may need restriction on the delay consumed inside the FPGA chip. So here there will be a requirement of maximum delay constraint inside the FPGA. Either it is through combination logic or without combination logic. We need a constraint that is called maximum delay constraint. In some cases, opposite may also be required, that we want to put a condition on the minimum delay constraint. We need this much minimum delay inside this FPGA. Now let us consider the other type of paths where we need to constrain input to output paths. This is the case when a data bus travels from input ports to the output ports. Again, here are two cases. One is without combination logic, another is with combination logic. But in some cases, the skew between these data lines in a bus is not tolerable. Hence, we have to constrain these data lines in a data bus. Friends, as shown in a figure, here I have shown two paths from input to output port. First one is like straightforward. Second one is little bit complicated. So if you leave these paths unconstrained, then definitely there will be a huge amount of skew between these two data lines. But this skew is not desirable. So we have to constrain these data lines. Friends, in this video we just discussed that how to constrain these input to output paths, and as per my understanding, if it is a data bus, then we need to manage skew between the data lines. Apart from constraining maximum delay constraint and minimum delay constraint on this data bus, if it is a single line only from input port to the output port, then definitely we need to consider maximum delay constraint and minimum delay constraint. And what are their proper syntaxes? We will discuss it in an upcoming video. Very soon I'm going to publish it. Once published, I will share its link in the description section as well as in the I-bar section. You can go through it. With this, I'm going to end this video session. I hope that this would be quite informative for all of you. If you also like this video, please press the like button and you can share your feedback in the comment section. And in future also we are going to create many such videos. So to be aligned with our channel, don't forget to subscribe it and press the bell icon to get the notification of all the upcoming videos. Thank you so much for watching and your time.